Thank you for coming to the last talk of the day, and I'm fully aware that I'm the last guy between you and beers, so if you don't keep me here, I'm not going to keep you here, so let's keep this mutual. My talks are going to be, it's called Metrics for the Masses. My name is Udo Kohlmeyer. I'm a Pivotal engineer, and I work on the Pivotal data side, developing Pivotal Gemfire, and a committer on the Apache Geode project. So, given that we're talking metrics, so let's, by a show of hands, who's ever heard of a library called Micrometer? All the Pivotal guys, you can put your hands down. You should know by now anyway. Of those people, who does monitoring of the applications or systems where they currently work? Okay. And of those who had their hands up, who thinks and believes that they are effectively monitoring their systems? Yeah, we got about a half. Oh, we have 1.5. Look at this. It's quite a lot. So I'd like to start this off with a safe harbor statement. Some of the things I'm going to be talking about aren't available quite yet. And also, I would like to add to this that I might potentially shamelessly be promoting a library more biasedly than anything else. So I'd like to start this with a story. So a few years ago, I used to be in the consulting business. And as part of my consulting job, I used to periodically go see past and previous customers that I was working at. And a particular customer, I walked in one day, and I was greeted by this customer with the biggest smile on her face. And I'm like, what's a big smile? And she says, you would not believe this. Yesterday, we discovered that 2 out of our 5 servers had fallen over, and we'd not known about this. And to top it all off, the system didn't waver, and it kept on working as it was. Well, you can imagine me as a consultant of the product. I'm like, yeah, baby, it does what it does. And you know what? It says so in the box, it works. And then a few seconds later, it's like, hold on. You lost 2 servers out of 5, and you didn't notice? What? So I was like, explain a little more. How does this work? And it's like, you know what? How do you monitor this stuff? And yeah, well, they had monitoring set up. The problem was that they were monitoring the wrong thing. What they'd gone and done is they were monitoring average latencies and performance and throughput, which of course will not show if a node goes down. And they'd never noticed or thought about actually monitoring the number of nodes that were there. So that's where I'm going to say, lesson to self, you know what? There's monitoring and there's effective monitoring. I mean, we can look at throughput and latencies, but unless you're in the high load, you will not notice something going that wrong. So I'd like to take a step back sometimes, and I'm going to say, you know, well, what does it mean to monitor? And the best description I can come up with was from dictionary.com, and it goes and says, monitoring is to observe and record and detect an operational condition with instrumentation that has no effect upon the operational condition. Now, the one thing we have to call out over here is that it has no effect upon. It's like a catalyst. It should aid something, but it shouldn't affect the outcome. So this is interesting. There's also, what are we monitoring? Well, we're monitoring some standard measuring or valuation of something. So this is the definition of a metric. So we are actually effectively monitoring some state without affecting this thing we're monitoring or the system we're monitoring with. So in applications, we generally have about 7 or 8, depending on what research you do and what you look at. We have 7 or 8 sort of different type of key application metrics we look at. We look at average response times, which we generally measure in milliseconds. We monitor error rates, how often something goes wrong, and that's in percentages generally. If we have clusters or we work in the cloud, well, we should monitor the number of instances we actually have running. We have the number of requests or rates of requests, so that's in operations per second. We generally want to monitor application system resources, the availability of the system, and for all us Java developers, well, the last one's pretty key, amount of garbage collection and how often that happens. Fairly key and standard sort of application things we want to monitor. So let's look at our standard monitoring setup generally. So the server in the middle is our monitoring application or monitoring software, whatever it might be. And we would like to monitor an application of the server. We generally go system administrator, we go into the monitoring software and go say, please monitor a specific IP address. And we go give it what we need to do. And as the system and applications grow we want to monitor, we add more and more and more to this. Well, this is pretty standard. Everybody knows what it does. But that is so last decade, man. With the advent of cloud, well, things went different, man. When we started clustering and adding more instances to the network, the poor system administrator had to keep track of who was added, where was added, when it went away, where it went to, how it got there. And eventually, with this just happening automatically with auto-scaling, something goes wrong, and the system administrator just blows up because he just can't keep up what's going up anymore. And 9 out of 10 times we end up, as in this diagram, we have a server that isn't monitored, but is available. Because the number of instances we monitor versus the actual number of instances we have lying around are not equal anymore. So when monitoring clustered systems, and this is from experience, having done this for 5 or 6 years in the field, when monitoring clustered systems or cloud systems, you actually generally have two approaches when we monitor things. We monitor using an approach called aggregation, or we use an approach called Sharednothing, where every instance in the world publishes. And I'll explain a little more what these things are. So the aggregational approach is really where the cluster or the number of nodes nominate a single node to be the aggregator of all the metrics. And they all send their metrics to that one node. And the responsibility for that one node who's aggregating all the rates is to collect the metrics, to aggregate them as something makes sense, and expose them to the monitoring software that's going to use it. Well, the nice thing about this is that we can actually transparently grow or shrink the number of nodes we have in our cluster or the number of instances we have available to us. So that becomes really great. Also, the aggregation node is now the one node that actually knows if there's any special rules or anything we have to apply to metrics to actually differentiate that single metric from server 1, so we can actually differentiate that same metric coming from server 2. So he has the responsibility to actually do this. Well, the downside to this, of course, is that that server can go offline. So now we have to go and have that server or that aggregator node to be highly available. And once we have a highly available or highly available nodes, we have to tell, or the poor system administrator has to go and now manually add that new highly available node upon failover into the monitoring software so we know where it goes. So then we get to the shared nothing or everybody publishes kind of process. And this one looks very same to the old sort of standard way we used to do things. We have every node that actually is registered with the monitoring software, which is great because, well, everybody gets to publish. We have no rate aggregator anymore, so we don't have a single point of failure anymore. And generally what happens is most servers have a low memory footprint because we actually don't have all that framework stuff to make sure that we're actually now publishing those metrics to the other side. The disadvantage of this, of course, being is that, well, we can't easily grow. It doesn't scale easily. I mean, as you start adding more nodes, somebody has to go into the system and actually start saying, okay, well, add these 3 or 5 nodes. Well, that's fine if you have 1 or 5 nodes, but what happens if you have 20 or 100? It doesn't scale on us. So working as a committer or working with Gemfire and as a committer in Apache Geode, we are a clustered in-memory data grid. So we get to play with clustering and having to know how to monitor this kind of things. And Geode has a sort of best of both approaches. And we actually use both. The first one is that we use an aggregational approach. Every node pushes some metrics, a subset of all the metrics, to our rate aggregator node. And he then makes that available to the monitoring software using the JMX interfaces. In addition to that, we have the sort of shared nothing, the shared nothing everybody publishes kind of approach where every node in the cluster publishes all the metrics we've defined or defined to be written into local disk in a GFS file format. So you're asking why? What's wrong with that? I mean, we have the best of both worlds. Where's the problem here? Well, the first problem we have over here is that, well, JMX, we have the aggregator node again. So we come with inherently all the problems that come with that. The second problem is that it's a subset of all the defined metrics we have within the system. So unless we've actually gone and made sure that we got all the metrics we want to expose to the JMX interfaces, we might have to go and manually add that metric or metrics into the corresponding MBeans. And to make it worse, if we want to then start some fancy aggregations, maybe some hierarchies, some drop-downs, all the kind of stuff inside there, this logic all has to be coded up using the MBeans. So we have a lot of manual work that comes into play over here. So let's look at the GFS file format. So the GFS file format is a proprietary file format. And it's on a per server basis. So we have two problems in that one. Firstly, it's proprietary, which means nobody else knows how to read it except a custom visualizer that we have or we push with the system. The second problem is that if I would like to get a complete end-to-end view of my metrics or a single metric across all my servers within the cluster, I have to load all these data files into this visualization tool. And while that works okay if you have, I don't know, 5 or 10 nodes, but if you're a really big customer and you have, I don't know, 50, 100 nodes, this simple visualization tool can really get overwhelmed really quickly. So this also doesn't really work well. So where to from here? So the one thing is that last year, SpringOne, I got introduced to Micrometer. I saw it, I fell in love with it, I never ran away with it. Now you guys hopefully have seen it. If not, go to micrometer.io, it is fairly a game changer. So the one thing that micrometer.io or Micrometer gives you is a standard set of generic meters, gauges, counters, timers, histograms, all this stuff that is not tied to a single vendor. And it looks, from an implementation and usage perspective, we can equate it to what sort of like SLF4J did for the logging kind of capability. The other thing it does really well is that it actually understands the difference between hierarchical and dimensional monitoring systems. And it can actually handle both really well. The other nice thing about this is it comes with pre-configured data binding, so we don't have to go and write extra little pieces of code to go monitor our JVM. So we don't have to care about how do I best monitor my GC pauses, how do I get my system resources, what's my CPU look like, all those things. It just comes as a set library and a set plugin that we can use. And lastly, the greatest thing of all, it integrates really well with Spring and actually is currently used in Spring 2.0. It is also backwards compatible with Spring 1.2 or 1.5. So at this stage, for those people that don't know what tagged or dimensional data is, you should have gone and said, hey, Udo, hey, what is this stuff? What are you talking about? I don't know what this is. And I'm going to use it as an example that I saw John Schneider and Josh Long present, and it goes and says, I have a web service, and I would like to track how many HTTP requests I have received. And the simplest way to do this, I create a metric called HTTP request. Great. And then I decide I want to know how many of those requests were gets. So then I create a metric called HTTP request get. And of course, I want to know how many are puts. Well, then I create a metric called HTTP request put. And then we want to know we're in a cloud, so we want to go what region where this come from. And you know, as you can see, this just gets exponentially worse and it gets really bad. And it can spin out of control really, really, really quickly. So what does tagged or dimensional data look like? So the simplest way to explain it is that we have a single metric, and this metric is called HTTP request. An HTTP request has a set of dimensions or facts, as we look in if we look at define what a dimensional data is, it says it's a metric that has facts attached to it. And the facts in this case is that HTTP request has a method of how it got there. And it has a region of how it got there, or where it came from. So when we actually start tracking metrics, we go and say, well, I have an HTTP request come in, and I provide some extra information along with it to go and says, oh, it was a GET, and it came from US Central A. I can do the same thing for the HTTP request for the put. So how does this help me? Well, the one thing is like I can use any tool that knows and understands how to use dimensional and tag data. I can actually go and say, well, give me the total sum of number of HTTP requests that I received in a time frame. And then I can drill down and I can actually go and say, well, out of those total numbers, how many were puts and gets? Or I can say how many of those came from US Central 1A and how many came from US 1 Central C. And then I can slice and dice at one more level, which goes and says how many puts and gets or vice versa. So it allows me freedom to actually now start taking my data that I've now recovered or I've actually recorded and making it work for me. And this is where we're going. We actually want to know where our data comes from. What is our pain points? Where do we see things going wrong? So being an Apache Geode committer, I'm putting a proposal in place to say, well, let's actually change how we work. Let's make it a little better and faster. So what does my proposal look like? Well, the proposal looks like, let's get rid of that GFS file format we store on disk. Okay? That's a little revolutionary. It's a lot of our stats just gone. All of us, our developers suddenly go and say, something's gone wrong, we can't see anything anymore. And then I'm going to say, one worse, let's get rid of the rate aggregation stuff. Why? Because we don't want that single point of failure anymore. Okay. Then we go and we actually include Micrometer into every system or every instance that we have from the Apache Geode cluster. We then get to select where we send our data to. Now, these are just, I think these are close to all the 12 that actually Micrometer supports out of the box. Prometheus, InfluxDB, Wavefront, Datadog, Ganglia, JMX, all of these guys you should know, seen them before somewhere else. And the nice thing about Micrometer is it says you don't have to just select one, you can select multiple. So maybe you want to send your data using to Prometheus and JMX. So you can actually have multiple data downstream. We can send this data to multiple downstream systems. And then finally, once you have it, you just turn it on and you push the data. It sounds very simple, doesn't it? So in my talk, Abstract, I spoke about Pivotal Cloud Cache. And why I talk about Pivotal Cloud Cache is that Pivotal Cloud Cache is based upon, on the sort of lineage and hierarchy, it's based upon Apache Geode. So if Apache Geode gets the Micrometer support, then eventually Pivotal Cloud Cache will get the Micrometer support. And what does it mean? Well, it's got in PCF world, PCC is deployed in the PCF world, and it has something called PCF metrics. And each of the PCC instances or clusters can now start pushing data to the PCF metric system using the Micrometer endpoint. Now, what does this mean in the greater scheme of things? Well, let's take it back and say, you know what? The whole drive is to go and say, I want to potentially move all my physical servers and all my clusters that are physically on my machines or virtual machines in my server room. I want to potentially put it into the cloud on PCF. You know what? That's what we want to do. With this, we have to do nothing. Once we have Micrometer set up over there, it will just automatically pick up in the PCF world and continue as nothing ever happened. You can even go as far as saying, you know what? Micrometer, you can be configured to go push the metrics off-site, so out of the cloud into, let's say, a local metrics or monitoring system you have in your environment or into your server room. Yes, you're going to have a public IP address so we can get the stuff in there, but once we have that, we can push to your local monitoring system. So as I said, this is still a few steps down the road. This is pretty much future. We could be going. What's really cool about it? So don't go and say, hey, I saw this at SpringOne, when do I get it? It's going to be a few weeks off or months off still. So let's have a bit of a demo. And the demo I'm going to present today is actually fairly simple. I've got a 2-host Gemfire cluster set up. It's actually configured currently to produce data. It's using Micrometer, and it's pushing data to the Influx database system, or time series database, and is using Grafana as a front end to query this data. So here's just a very simple dashboard. I have got a tag over here that goes and says the number of servers. I have one over here that goes and monitors the number of entries I have in a region. Now, if anybody has attended any of the data sessions today, you would know what a region is, but for those that haven't been here before, a region in the Apache Geode or Gemfire or even PCC world is equatable to a table in a database. It's just a place where we actually store our data. It's a key value kind of store where we put the data. It's pretty much just a map with a whole bunch of very cool stuff hanging off it. Then, of course, we have the JVM memory usage over here. So I actually currently displaying the max memory, and I'm actually showing 4 nodes over here. So these 2 nodes at the top over here, so let's actually zoom in a little. These 2 over here, the SP1-1 and SP1-2, those are what we call Gemfire or Apache Geode locators. Not really relevant to this thing, but it's something that we require to actually help with the cluster formation. And the ones at the bottom here, 3 and 4, those are our servers where we're going to put data into. Also, what we have over here is what we call primary buckets, and a list of primary buckets. And not to have to go to too much theory about this, but when we store data in Geode using a mechanism or a region type called partitioned region system, it's the one that actually goes and says, I'm allowing you to scale horizontally. You can actually put more data as you have more nodes because it scales horizontally, and the way it does it, it actually stores data in buckets. So all buckets matching a certain hash requirement get put into the same bucket. And we have the notion of primary and redundant buckets because we need to care about redundancy. So we have primary buckets, and those are the ones that actually are accessed all the time for reads, not for reads, for writes. And we want redundancy because, well, if something goes wrong, we at least don't lose the data. And of course, the last one over here, which quite nicely goes and says buckets without redundancy, I just aggregating on a higher level of how many buckets are not made redundant at this point, or we don't have redundant buckets for this. I don't have copies lying around. So let's just have a quick look at sort of what this looks like. So I'm going to look at this number over here, and what I've done is like, here's the query. And this is running, as I said, it's running against an InfluxDB system. If I were to use Prometheus, this query screen would look slightly different because it's tailored towards Prometheus rather than InfluxDB. So Grafana knows what its data source is, where it's coming from, and it tailors its screen and its query capability according to its data source. And all I'm doing over here is like I'm looking up a metric called distribution nodes, and I'm telling it to find the last known entry for that entry, or for that metric. Now, I can go over here and I can go say I have tags. Now, as I said, I have dimensional data. I have tagged data. So I have tagged this data by default already with the server name. Because I might actually want to, well, this metric doesn't make sense to actually go and say this, actually split it by server name, because I just want to know how many nodes I have available. And maybe process ID, and that's it. I mean, there's some other ones that actually look a little better about this. But this gives me the single number of there's 2 servers. And as I said, I already have started 2 servers, so it's showing me 2 servers. Let's look at, let's say, primary buckets. Primary buckets is a nice example. It goes and says, well, I'm looking at a metric called region partition buckets primary count. And what's interesting over here is, like, you can see the bottom in the group by tag is I'm grouping it by the server name, and I'm grouping by the region name. So I can actually go and understand, you know what are the difference counts on a per region, per server basis. So it gives me, but the metric is just region partition buckets. So I can actually, if I wanted to, I can get the total number of buckets, primary buckets I have available, but I can split it between the 2 difference and get an aggregation. So let's make something happen. Let's actually start some data population in here so we can have a look at this. So let's start the client. So this guy is just set up. He just, under the covers, he will just connect to one of the 2 regions and start pushing data into the cluster. And we should, over time, start seeing things happening over here. Just give it a time. It refreshes every 10 seconds. So let's drop that a little, maybe. To every 5 seconds. So let's see, I'm not hope I'm cursed by the production live demo. Let's just make sure it's running. That didn't look good. Oh, that's fine. That's not a problem to worry about. So I've actually turned off, currently I've turned off my population. So my client is actually configured, or can be configured, to send metrics up to Influx as well. Seemingly I haven't cleaned it up enough that if I don't publish it, it doesn't throw me errors. Let's see if this thing refreshes. Oh, well, there's something happening. Okay, so it was just a bit of refresh. So as you can see over here, we have the entries per region start going up slowly. I have 181 entries in region 3, and it keeps on going. And then you can look at primary buckets over here, and you can start seeing those increase. Now, by default, a partition region has 113 buckets. So we should see that between region 1 over here, between these 2 servers, 4 and 3, those 2 numbers should eventually end up to be should add up to be 113. That's why I know how this thing works. Now, the reason why this view, this primary bucket view, is really important is that we can use this view to actually understand how well our data is distributed across my nodes. That is very important, because you don't want one node to actually have majority of the data just because our hashing function wasn't right, or the number of buckets we don't have right. We have a very skewed data set. So here we can sort of have a very high-level overview and saying, hey, how well distributed is my data? So as we keep on adding, I'm not going to worry about this too much. So let's go and say, well, this is my monitoring system, and I haven't touched it in any form or fashion, and I'm not going to touch it in any form or fashion. This is where the power of tag data comes into us. So let's go and say, hey, let's start server 3. I'm going to start another server here. And this is going to start it off and kick it off in the background. It should come up, and let's have a quick look over here and see what's happening. And we should see, without any changes that I haven't made any physical changes to the system, but I should now see, hey, there's server 3 popped up over here, so now I have 3 servers here. I should see another server pop up over here. So now we have servers 3, 4, and 5, all storing data for region 1. And I haven't done anything. So now we have the situation of where servers can come up and down, I can scale up or down, and the monitoring system doesn't have to know about this. So let's actually do something cool about this. Let's actually go and say, well, how many operations are we doing? Let's have a look at that. Let's just actually see what this thing would look like. So let's start. This is the way you started off. In a second, let's enter a graph, and I'm going to say, well, what do I want to measure? So I want to measure something called partition, if I can spell, partition operations completed. And this is now going to be another metric I capture. Now, this is across all my servers. This metric actually comes from across all my servers. Now, a time series database will have an entry for every server that sent this data, so I need to now be a little more smarter about this. So I want to go say, well, let's remove that guy first, and let's go say, well, let's group it by server name. So I'm now grouping by server name. It's telling me I haven't done a properly selection yet, so let's say, well, give me the last number you have received for that server name. So now I have the number of operations on a per server basis been popped up over here and populated. I haven't done anything yet. I mean, this is really where I've actually put the power into the guys that do the monitoring software to go and say, hey, let's use the system as best as we possibly can. And let me just check the time. Oh, I'm going to start running short soon. But this is how simple things become. I don't have to care about it. I can actually start another server, which is actually another one I want to do. Start server 4. And once again, without having changed anything, without having touched the system, let me just actually take this one out because he's not really relevant at this point. I should see number of servers bump up to 4. I should see my memory management over here at the bottom left to actually include another server. So I have server 3, 4, 5, and 6 popping up over there. I haven't touched it. So it's suddenly just doing things automatically. Now, the one thing which is actually really impressive, and this is something we have to care about, and especially when we have redundancy situations and we have failure situations, let's go and say we lose server 2. So I'm going to shut it down over here. Now, what's going to happen, and this is potentially just a tooling thing, something I think unfortunately that I can change about this. Maybe it's my lack of knowledge about the tool, but given that I'm actually looking at data for the last minute, you will still see server 2, which is actually server the SP1-4, still being in my graphs. Because in that 1 minute period, I can still find data entries for that server. So if we just keep on watching it for a while, we'll eventually see that SP1-4 will actually disappear out of our graphs. But what we can see over here is that this number of servers of 4 has now reduced to 3. I can put an alert on this. This is something I can easily put an alert on and say, hey, if my number of servers have dropped within certain numbers, alert me on this. So this is something we can easily do now. The other thing which becomes really interesting is this buckets without redundancy. And I spoke about that we have redundant buckets lying around. We have to always have at least, well, to not lose data, we want to have at least one redundant bucket lying around. And this thing is suddenly telling me, hey, hold on. Region 3 and Region 1 both have a number of buckets that are not redundant at this point anymore. And I can guarantee you 53 is the right number and 51 is the right number. I've worked it out and said, oh, these numbers look a little high, but it's really got to do with the number of primary buckets and the number of redundant buckets that were on that server that have now disappeared, and where we actually have to get this information from now. So it actually is correct. So as you'll see over here now, SP1-4 has disappeared, and the same thing over here. It's disappeared out my list. Now, this is really great in the sense that, well, we can actually, things come up and down. We can scale servers up and down. If we're in the cloud environment, we have the Oprah moment where we suddenly have to scale to 100 nodes. We don't want to carry all that 100 nodes or registration of those 100 nodes around for the lifetime of our system. So this thing will automatically go up and down. So let's go back to the slides because I think we're going to run out of time soon. So what is the future, really? Well, the first thing over here is here's this Apache Geode. So Apache Geode follows the Apache process of how we get data. And Geode 5775 is the Jira that is the one that will bring Micrometer into Apache Geode. And if you want this, go to that Jira, upvote it. I don't care if you upvote it 5 times, make sure it comes up, because that just motivates us to go and say we want to get this into the system. Once we get that done, the next step would be we want to integrate Apache Geode, or the Micrometer-enabled Apache Geode with Spring Boot Data Geode. That means that Spring Boot Data Geode can now show and integrate easily, or its metrics capturing system or statistics capturing system will integrate with Apache Geode seamlessly and get us metrics from there. Simple statement. Next one is Pivotal Cloud Cache. Of course, we'll get the Micrometer integration, and we'll have to go and see what that means for Pivotal Cloud Cache and where that fits and what needs to get done. But the one thing I do know that is actually going to be a bit of a hindrance to get for PCC to get this is that currently the PCF metrics system cannot handle tagged or dimensional data. But I have it on good stead that the research and, well, the research is currently being done, and people are looking into this, how we're going to support tag metrics within PCF as a whole. So whole PCF will actually suddenly know how to handle dimensional data. So this is a benefit for everybody, not just PCC. And with that, I'll turn it over to questions. Not? Oh, yes.
So you mentioned that you were accumulating data using DB, that
InfluxDB, yeah.
right? And you were using Grafana over the top of it and you monitoring, right? But that doesn't send alerts, that's just a UI, right? That you're collecting data on.
Yes.
How would you basically get email for alerts in case?
So just to repeat the question, so your question really is, the fact that I'm actually pushing more data to Influx and I have a nice pretty UI like Grafana to actually display this data, how do we actually, from a system application or monitoring perspective, how do we get the alerting done? Well, Grafana is actually a real monitoring system in the bad world. They actually do have the capability to turn on alerting, so that is something that Grafana can do out of the box. The other thing you can look at is there are, let me actually get to that page. Yep. If you look at Micrometer, it actually supports pretty much all the big monitoring systems out there. New Relic, Datadog, Wavefront, SignalFX, Prometheus, Ganglia Graphite, all of those. I think even Elastic is on there. I didn't put Elastic on there. But all of these know, in some form or fashion, or of the proper monitoring applications, I think they know how to do alerting. They know how to go and say, oh, my rates or my average response times have varied within 10%. I can now send an alert. So what we're really doing is we're actually telling Apache Geode, and we're telling it, you know, we're just going to send metrics, and we're going to have the alerting and the aggregations and all the fancy stuff you want to do about how you check your metrics. We hand it off to systems that specialize in that. It's not a speciality that Apache Geode needs to worry about. We are an in-memory data grid. We're not a monitoring software grid. So as I said, yes, I'm currently using InfluxDB, which is a time series database, using Grafana. And Grafana knows how to monitor, how to alert. So it's one of the tabs on there. I mean, I haven't played with it, but I do know that's a commercial availability they can do.
Do you have a preference?
Sorry?
Do you have a preference in terms of Prometheus or InfluxDB?
Do I have a preference? Me personally? No, not really. I think all of them do their job equally well. It's just what each company has and what they've invested in. I mean, I know that some companies have Wavefront just because they're a big VMware shop, and other people like to say, well, we're more open source. We want to use an open source thing. But it's no preference. As I said, Micrometer and when Apache Geode uses it, will not have a preference either. We're just going to say, oh, you want to use Prometheus? Well, we know how to push data to Prometheus. So there's no preference in that area. Any other questions? Yes?
Micrometer pushes the data to the InfluxDB automatically, so is it like some batch or something? How does that push it? InfluxDB is a separate server, right? How does the data from the instances get pushed?
So how does Micrometer push the data to InfluxDB? So the simple answer to this one is that we have set up the InfluxDB connectivity, so we know the host. So when you start InfluxDB up, it starts generally on default port 8086, and there's of course we know what the server is. We tell Micrometer to push all data to the Influx, so it has an SPI. Micrometer has an SPI, so each of these vendors have written their own implementation of this SPI. And it knows how to do this. And it happens on a periodic basis. So you can decide how often it happens. Does it happen every second? Does it happen every 10 seconds, every 1 minute, whatever what you want to configure. It also sends the data in the format that this downstream system understands. So it doesn't go and just have some generic format. It actually goes and says, oh, I know influx data. You like it to be in this format, so it will take each of the meters, grab all the information, and send it there. And this all happens in a backend thread. So it actually isn't part of your synchronous processing. It's as per what we have a definition of what monitoring is. It shouldn't be part of your system and shouldn't affect your system in that way. So it's a background thread that will spawn, it will run however long. This ran every 10 seconds. It just got all the information and sent it downstream. So as I said, if it writes to Influx, it writes it in a format that Influx understands. If it writes to Prometheus, it writes in the Prometheus standard. If it uses JMX, well, it displays the way JMX knows how to do it. So it does all these things quite nicely for you. One more. Splunk? Not off the top of my head. I don't know. You can actually look at the micrometer side, to be honest. I know yeah, I'm not going to even try to answer that one. I know there's a system that actually that's on top of Splunk, but I don't know exactly off head now. Yes?
Does Micrometer can Micrometer write to Geode itself, like some other cluster?
So right now, Geode hasn't implemented this SPI, and I'm just a committer. Therefore, I can't really go and say yes or no. Right now, there hasn't been a request. There hasn't been overwhelming saying we want to do this. Once again, Apache Geode is not going to be that specialized because this is time series data. Apache Geode doesn't handle time series data as of yet. And it's a sort of very niche kind of area, so it's not quite really where Apache Geode wants to play in the sense of we want to have data stored on a sort of more generic map kind of structure. But once again, if there's enough requests, enough groundswell, and enough sort of PR requests, hey, we want to have Geode potentially somewhere along the line working, well, as I think our Josh Long always said it, I will work for pull request. Anything else? Well, with that, I thank you very much, and I enjoy the rest of the conference.